Hi, everybody. So can I just start? It's 3 p.m., right? All right, it's just on time. So I'm Nat Sakimura, senior researcher at Nomura Research Institute, and I'm also the chairman of the OpenID Foundation. Is there anybody who knows about me? Like how? Okay, let me do a little bit of introduction and go on then. All right, so I'm Nat Sakimura, as I told you, and I have, please go back. It's jumping forward, right? It's kind of a fun thing to do. My contact details are there, so you can get in touch with me that way. And this presentation is trying to give some kind of overview on what we do to secure the APIs beyond basic OAuth. By basic OAuth, I mean RFC 6549 and 50, right? Which is very, very common these days, but it has its issues. But with only 20 minutes, I cannot go into the very much of detail. So, I plan to do a follow-up on Twitter or my blog or my YouTube. So, it's good that you can get connected with me through those social medias. So, as I told you, OAuth is a framework. I thought I'm going to see my screen down there, but I'm not seeing it, right? So, the OAuth itself says that it is a framework, and it says this framework is designed with a clear expectation that future work will define prescriptive profiles and extensions necessary to achieve full web scale interoperability. That means, sometimes it may just work, to do a stock OAuth, but in many cases it doesn't, right? And oops, jumping forward. All right, and so when we talk about profiling it, we have to find out which OAuth options we are going to use, because these are all the list of the OAuth specs. And each spec has many options. And you have to decide on what options to take, right? That takes care of the particular security profile that you want to achieve, right? In this diagram, I have depicted the horizontal axis as the high to low environmental control. On your left is the high environment control, like in the closed circuit system. And on your, it's a little bit hard. On your right, oh no, please stay. On your right, the low security, environmental control, like this slide, all right? But the internet is a low security control kind of, environmental control place. So in the factory or closed circuit kind of setting, it is okay to use stock bearer token, RFC6749 kind of, bearer token usage. While in the, higher end financial API sort of, that goes over the internet, you have to find out something better than that. And for that, we've been working for the last 2 years, and I think we are having some kind of plausible answer, which is called Financial Grade API. The acronym is FAPI, Security Profile, which is a general purpose high security profile for OAuth. It tries to take care of those, upper right, the orange space, the high security, high value transactions with the low environmental control. And the FAPI security profile is made up of a bunch of OAuth-related specifications. PXE Okay, yeah. All right. I'll just give up this one. All right. RFC7636 is called OAuth Pixie. And then there's something called OAuth jar, which I hope to get the RFC number by today, which I didn't. It's in the queue of the RFC editor, so it should come out any time now. But this is the kind of OAuth which takes the authorization request message and authorization response as completely protected by the digital signature. And hybrid flow is something defined in OpenID Connect, which also helps with the integrity of the messages. And then we are combining that with sender constraint tokens, which is being worked on as the MTLS, mutual TLS profiles, which is being worked in the IETF's OAuth working group, as well as the token binding. Have you guys heard of token binding? Yeah, right. Right. So we, in the beginning, tried to use token binding only, but then, since we had to implement these standards this year, the infrastructure support level of the token binding wasn't there. So we had to come up with MTLS method as well, and it's been it's been adapted by Open Banking UK. All right, and next please. Okay, and 9 major banks in UK actually went live, soft live, this January. So it's been done pretty well. Okay. Next slide, please. And it's also recommended by Japanese Bankers Association. And US FS ISAC is also aligning the security requirement. Next, please. Yeah. With the FAPI. So it's been adapted pretty well. And I know that Australian banks probably is going to use it as well. And major IAM vendors are also implementing it. So you'll get pretty good support. Next, please. And we have also submitted to the ISO TC68, and it's a part of the forthcoming technical specification. There are some discussions going around it that it should probably be pulled out and made into the independent spec rather than putting it into the so-called web API specification that TC68 is coming out, because the security profile by itself is useful, but we'll see. Next, please. And we have, to date, issued 2 implementers draft. Next, please, which employs the redirect approach. Part 1 is read-only security profile, and part 2 is read and write security profile. Here, I said it takes redirect approach. Other approaches are decoupled approach and embedded approach. Redirect approach is the standard OAuth kind of OAuth dance. It goes through the browser. We call it user agent. And decoupled approach actually doesn't. The user interface, the service consuming device actually stays at the running party, and the authorization is done out of band using something like a smartphone. And embedded approach is the approach which is negotiated by some of the fintech companies in PSD2 in Europe that is kind of traditional thing. The running party actually takes all the user credentials, and through it, it's going to be passed to the identity provider. Now, that's a legitimate kind of phishing, and it's got its problems. And we argued hard that it shouldn't happen, but it's now mandated by law. So we have to find out a less evil way of doing it. Now, coming back to the redirect approach, next slide, please. As depicted here, the RFC6749 actually doesn't protect the front channel transactions. In this picture, I have three actors: client, authorization server, and UA, user agent, right? And the communications between them are TLS protected. But when the communication between client and AS goes through the user agent, the TLS is terminated in user agent. Therefore, attacker can come in there and modify the message, swap the message, and do all sorts of bad things. That's depicted in the table on your left, right? It's saying that it doesn't do the sender authentication, nor receiver authentication, nor message authentication. It's okay like that in a low-risk scenario, but it's probably not for financial transaction or other high risk scenario like healthcare or something like that. Next, please. Next, please. Yeah. So what we have done in FAPI working group is to combine various options available in various specs in the OAuth so that all the communications are actually properly authenticated. Authorization request is protected by something called request object, which is a part of the OAuth jar spec. And also, it's been there in the OpenID Connect since 2011, 2012, right? And the authorization response is protected by hybrid flow, which is defined in OpenID Connect. In the hybrid flow, something called ID token comes back with the code, right? And the name ID token suggests that it is something related to the identity of the person, but it doesn't have to be. ID token, in this case, is a detached signature to the authorization response, so that if something is tampered, changed, the client can actually find out something fishy is going on. Next, please. Now that we got the token, by exchanging the code. By the way, code obviously is in the authorization code flow with the confidential client. It is bound to the client with the client credentials, so that's fine. In the normal RFC 6749 and 6750, we are using something called bearer token. Do you guys understand bearer token? The example of the bearer token is like I have put the picture there. The picture you're seeing is the Paris Metro and Toronto Metro. The round token thing is the Toronto Metro thing. And, oh, please go back, right. These tokens are usable by anybody who holds it. So even if you lose it and somebody picks it up, the person who picked it up can actually use those tokens. It's convenient, but has lower security. So in the case of the OAuth, if the resource goes rogue or got hacked, and the attacker get hold of that bearer token, then that bearer token can be used by that attacker. Instead of using bearer token, in FAPI, we decided to use something called sender constraint token. Do you guys know about it? Have heard of it? All right. Most people know bearer token, but most people don't know about sender constraint token. Real world analogy of sender constraint token is airline boarding pass. Unlike the Paris Metro ticket, airline boarding pass actually has your name on it. And when you're using it, you actually have to show your passport together with it, right? And if the name and face doesn't match, you can't use it. So even if you lose your airline boarding pass and somebody picks it up, the person who picked it up cannot use it. That's the property of the sender constraint tokens. In case of the OAuth, we are embedding the certificate or the client asymmetric key information, public key information into the token, so that token needs to be used with the client's signature generated by the client's private key, right? So even if the token was stolen, it cannot be used, which is a good property, right? And that's what we are doing with the FAPI specification. And for that, we are actually using MTLS and token binding. Both specifications are available in IETF's OAuth working group. So please go there and read them. Next, please. Right. And in FAPI, all of these requirements are in the form of the checklist, right? So what you're seeing is just one section, section 5.2, read and write API security provisions. It's from the FAPI security profile for read and write. And when you look at it, down there, it says 5.2.2, the authorization server shall support the provisions specified in clause 5.2.2 of Financial API Part 1, Financial Grade API Part 1, read-only API security profile. In addition, the authorization server for the write operation 1 shall require blah, blah, blah. So it's all the requirements are actually numbered, and it's easy to build the conformance against it. So that's the kind of important thing that we are trying to do it. Next, please. Also, crypto requirements are tightened for interoperability and security. So if you look at section 8.5, TLS considerations, we are just defining 4 cipher suites. We don't allow anything else. That's going to tighten up the TLS a lot. And it also helps with the interoperability. And also in 8.6, we are defining JWS algorithm considerations. And it's saying JWS signatures shall use the PS256 or ES256 algorithm for signing, right? I have been hearing, I'm an author of JWS as well, and I've been hearing a lot of complaint that JWS is insecure because it allows algorithm none and other low security algorithms. Yeah, if you allow them, it is. But there are legit use cases that want that kind of algorithms as well in a very closed circuit system with a very low CPU power, something like that. You have to resort back to that. That's why we are allowing it. But there's no reason to use weak algorithms in the setting like this. So we have tightened it up. And with this kind of constraint, it is actually very easy for the application developers to build a negative test that, so that you are sure that you are only supporting the right algorithms. Next, please. Now, that was a redirection approach, and we are also working on other flows as well. The one we are currently working very hard is the decoupled approach, which is based on client-initiated back-channel authentication, CIBA profile. In this case, the client the application, stays on the user's consuming device screen. And there are a couple of ways of doing it, but at the end of the day, the authentication actually happens on another channel using smartphone or something like that, right? So that the client, on the client side, they can stay on the same screen. And that will hopefully alleviate a lot of questions and uneasiness from the TPPs, the third-party providers, right? One of the complaints against the redirect flow from those application developers were that the users were taken to the IDP, right, or authorization server, and they lose control there, right, because they might not come back to the application itself. And that was one of the causes for reluctance to adopt that, and they were, because of that, asking for something called embedded approach, which takes users' username and password into the relying party application and pass it along to the IDP, but that's a very bad model. So we're working on it, and if you're interested in working on something like that, please do come to the working group now. Within a couple of weeks, we'll be probably finalizing a lot about this flow. Next, please. The last, please bring it back, yeah. The last one, which we will be working on, is the embedded approach. Unfortunately, it is mandated by EU PSD2 RTS. It's law, so we have to come up with something that does it. But giving the user credential, like password, to the relying party, it's a legit phishing. It's bad. So if we had to do it, we have to find out lesser bad of the things, right? And what we are thinking right now is perhaps create an app, per app password or a per app access token on another device, and give it as an application password to the relying party. That probably is the least bad way of doing it. Next, please. There are a bunch of other things that we are using as well. We are doing as well. For example, open banking, OpenID dynamic client registration specification is being worked on. Next, please. And also, intent registration endpoint is being discussed. Intent registration is such that the TPPs clients can push the payment intent or something like that to the authorization server. It's staged there, and you just take the intent ID on the front channel to the authorization endpoint so that the user can actually authorize the transaction. It's got a bunch of nice properties because that you could just do the authorization, and later, after the delivery of goods or something like that, you can actually capture the payment, things like that. And it's a common pattern in the payment industry, but everybody is doing their own flavor of it. So if we can come up with some way of standardized way of doing it, then it will be really good. So, after we are done with some of the critical issues, like CBA and decoupled and embedded flow, we might tackle on something like this. Next, please. Now, how can we tell that implementation actually conforms to the specification? Next, please. We are in the core OpenID Connect. We have something called OpenID certification. It's a self-certification model. We offer the test module so that you can actually test your implementation against it. And once it passes every required test, you can declare the conformance and get listed in the OpenID Foundation's and OIX site. And we are thinking of something similar for the FAPI profiles. For the details, please go to that URL. Next, please. So all of these works are being intensively worked on at the OpenID Foundation's FAPI working group. This is the URL for the working group. So if you're interested, please join. Next one, please. And with only 25 minutes, I could just skim the surface of the things. And I have these accounts there, right? And you can get connected with me if you subscribe to those channels. And I plan to start doing more regular explanatory sessions over YouTube or something over my blog. So if you're subscribed to that, you'll see more details. Also, you can ask me the questions, and we can perhaps do the open discussions around these issues, and that's going to help all the people involved in the industry and ultimately to the customers of ours. All right, so that's my presentation. Do I have time for
You got a
questions?
couple of minutes. The next session starts at 3:35. Any questions for Nat? First of all, thank you very much. Questions? Got one here.
Going back to the security.
Please use the mic.
Sorry.
Please.
Going back to the security recommendations, you specifically called out a hybrid flow. Why would you do that over, say, an authorization code flow and have everything go through the back channel? Like, why would hybrid be chosen?
So with the authorization code flow, the authorization response is not protected, right? So attacker can actually swap the code. There's an attack called code insertion attack. With a hybrid flow, the ID token, which is a detached signature to that code, actually comes back with the code. So if you inspect the ID token, you'll be able to find if the code has been swapped or not. The same applies to the state. There's a state swap attack, right? So that's why we're using hybrid flow. We're not using it to convey the subject identity. It's just the signature to the response.
Nat, when you stress the use of TLS, and you're not talking like some kind of hybrid mutual auth kind of thing between the three, the different parties with your triangle, I wasn't quite sure because, I mean, the exchange of data, typically you would use TLS, so I was wondering if there was something more to what you were saying.
So the communication between the client and the user agent is TLS protected, right? It's the usual thing. Client and the authorization server is also TLS protected. User agent and authorization server is also TLS protected. But within the user agent, it is not protected. That's one thing, right? That's what we are protecting it. The other thing is that when you're using tokens, right? We wanted to bind it to the TLS channel. So these are two TLS considerations.
Any other questions? No. Again, thank you, Nat.
Thank you.
Next session at 3:35.